basically I can't get it to go fast enough. But you can, I definitely think you can see the bulb get dimmer. And the impact driver there is struggling slightly under load to get this thing up to speed. But I think what this shows is that this alternator is fine, this alternator is knackered, and this alternator is also knackered. Right, I've got a new alternator. This isn't it, I'm just going to repeat that experiment from, well, yesterday actually. So I'm on the battery warning light connection with the bulb, which is the right hand terminal on the plug as you look at it from the plugged in position. So there it is, yellow on this particular plug, and I'm going to spin the whole thing round not with that one, with this one. And there is no hang on, was it connected to the battery end? Yes, it is. There is no light, and therefore the light can't go off. So that's that then. Okay, so put that one aside. Might as well keep the plug plugged into it because it's not used for anything else. So the same experiments with the big alternator. Whoopsie daisy. Big alternator. Nice big lights. And if I spin it over, well, I think you can see it's dimming, and that's because my drill isn't, or what, my electric spanner isn't going fast enough. Anyway, that was where we were yesterday, and oops, put this one aside. And here is another of the micro alternators. So, put the bulb onto the appropriate connection. Where's the thing? There it is. Onto the battery post and connect. And there it is, it's coming on, not as brightly as the other one, interestingly enough. Well, that's interesting, it's not going out. Which is the same as the old alternator, which is in fact this one. That one does exactly the same thing. Interesting. Now, of course, in this setup, what I'm missing is the ignition on. For that, I'll need the other connector. So I could just check that the... Yeah, that's the bulb one. So So for that then, I will need another piece of wire to connect through to the battery or ignition on connection. So I need a piece of short piece of wire. Oh look, it's even got a clip on the end of it. So that is the battery. This is the ignition coming on. Okay, that's pretty conclusive. So as soon as I turn it over, the bulb goes out. And of course, what this makes me wonder is about the original alternator. Which I'm now going to test, and I'm actually hoping that it doesn't work. Because that would make me feel very silly if it does work. Okay, so we'll put the bulb on there. I'll put the other side of the battery on here. We'll switch the ignition on, kinda. Put the bulb on, as before. Well, that actually makes me feel more cheerful, because this one doesn't go out. I thought it did for a minute. Did you see it? That's probably me just slipping slightly. Okay, and just because I'm a bit paranoid, I'm going to check again the new one. So, the bulb, which is the blue wire, goes on that pin. The kind of ignition goes on the other pin. We switch the we need an earth, and we need a battery. So we're going to switch on, kind of switch. This is not a very good connection. That's better. I'm going to switch on the ignition, thus, and to earth the bulb, which comes on, and spin it round. And that's that. It works. So what is possibly also interesting about that is, did you hear the I don't know what the impact, the clicking sound that you get if you spin this around like that? There's no, that noise is missing. But when I did it on the old alternator there, it just span around without clicking. On this one, there was clicking, and I think it's just showing us a bit of effort going on the part of the alternator, because funnily enough, it's actually, yeah, it's actually charging the battery, whereas this one is not doing anything. So good. That's that little bit of an experiment sorted out. Yeah, actually, that's hot. I don't know why I'm surprised by that, but that goes to show that, yeah, in fact, there is a car battery on the floor, and it was charging it. And this little thin test wire here wasn't really thick enough, to be fair. So anyway, that was just for an experimental process. Okay, so that's that. Disconnect everything. That's my bulb, that's my alternators tested. So I have in fact got two dead ones. A pretty old, well, not that old actually, it's about 5 years old. It's become faulty, I think, due to not being earthed properly on the engine. The mounting bolt, one of them became loose and it was vibrating around, which I didn't notice. And I think that's what's caused that to fail. This one, which is brand new, well, bought in October, this also seems to be faulty. Why is it faulty? It could be because I didn't correctly wire it up, which is a real shame. But that's that then. So we've got two dead ones. I wonder if I can get new voltage regulators or diode packs, whatever it is, for either of them. So it would be nice to have that available in service. Right, well, I've been doing some more experiments, let's say, on this alternator charging business, and it appears that the result is a bit different from what I was previously led to believe. And the crucial difference is the sort of alternator which is actually under test. Now, here we have one of those micro alternators. Here it is, and as previously suggested, if I put the bulb on the from the bulb connector to the main output from the alternator, earth and everything, there's a battery down here on the floor where you can't see it, and I shall make it go round using my impact driver. Nothing. This is a alternator which I was previously suspicious about, but because I've also got a brand new alternator of a very similar sort, and that did exactly the same thing. So I thought, uh-oh, wonder what happens if you connect up the ignition connection as well as the bulb connector. So because it's all connected together, there is the ignition kind of coming on, and here we go. Now you probably won't be able to see this, so I'll just read it out to you. At the moment it's showing 11.2 volts. What happens if I drive it round? Well, it reached 12.3 for sure, and a minute ago when I tested it, it did actually reach 13. I'm slightly reluctant to drive it ever so hard with this because it's an impact driver. The reason I'm using it is because that's the only thing I've got that will fit the nut. It would have been better with a drill, really. I don't really want to drive the nut further on than it can be, than it absolutely needs to, but I'll just try once more anyway. And now you can hear my compressors come on. I'll wait for that to charge up. So again, put the bulb onto the main alternator output. The ignition wire kind of is also connected there between the secondary, the I connector on the control plug, and down here where you can't quite see it is indeed a car battery. So here we go. So my meter is currently showing 11 and a bit volts. And that was 13.07, and probably even this thing isn't running at full speed. So what that says to me is this alternator is working, which is a real disappointment in a way, because I thought that it was faulty, and by the look of it, it's not faulty. It was driving the bulb, obviously, it was charging the battery. Must have been, because it was over 13 volts and the battery obviously sits at 12. So yeah, what this shows to me, both connectors on this type of alternator need to be connected. So I'm going to guess, or I'm going to wonder, whether in fact the same is also true for this one that didn't appear to work, which I thought was not working because I'd blown up the regulator. But Really? Let's check that one as well. So put the battery connector on. I have to check which is which on the Type 4 connector. So the left hand one is one I don't need. The middle one is for ignition. So this is the one that requires the ignition thing to be connected, which I shall now do. The right hand one is for the bulb, which is here. So same principle as before, except I'm going to add on the voltmeter, which I didn't do yesterday. Voltmeter connected. Here we go. So we've got a voltage of just over 12 volts. And if I put the bulb on, it drops a little bit. And if I spin it up, what happens? Now, interestingly, I only got 12 and a little bit volts out of that. You saw the bulb went out. Ooh, got a bit of a short circuit going on. Yeah, that's quite hot. Yeah, definitely a bit of a short circuit, but no harm done, I think. Better check that it doesn't happen again. Alright, so try that experiment again. So we have 11.9 volts. To be honest, I didn't really get above 12 volts on that, but you could hear it working harder. So one of the characteristics is that when there's no charging going on, the alternator kind of freewheels. As soon as it's doing some work, it doesn't anymore. Right, so having tested my so-called failed alternator, or at least one of them, I thought I'd better retest the other one, but as you will have seen a minute ago, I couldn't get it to do anything, almost certainly because I couldn't get it to spin fast enough using the impact driver. So I've gone to the trouble of actually fitting it to the car. Now, you won't be able to see that because it's, I'm going to come around and show you. I'll take you on the tour. Yeah, the micro alternator, of which I have two here, plus the one I'm about to show you, is necessary because on the Blacktop Zetec installation I used a fabricated plenum chamber, I forget who it, Kit Car Parts Direct, relatively readily available. But it did require the fitting of a small alternator, and here it is. That's why I'm bringing you around this side of the car. Let's put a light on it. There it is. There it is, fitted to the underside of the inlet manifold, because obviously the full-size one wouldn't fit, which is how we came to use any of this stuff in the first place. So anyway, I've gone to the trouble of connecting it up, and this is the one with a 3-pin plug, hence these connections here are via trailing wires, and they will probably become permanent eventually, assuming I stay with this alternator. It's a pretty neat installation, but it appeared not to be working. So, oh, did I bang your head? So this is what this has been all about. I couldn't test it with the correct electrical connection. I couldn't test it using my pneumatic impact driver because I couldn't get it to go fast enough. So I've obviously fitted it to the engine. Now I'm slightly cheating because I know what's going to happen. So the key thing is the voltage. Now if I point you directly at the voltmeter, Hopefully you can see that that says 12.68 volts. Now I know that that tends to be a bit, you've got a very wide angle lens there, so I hope that's well enough lit to show. And so now it's wired up, physically fitted. Now start the engine so that it runs at a proper speed. What happens? There we have 13.8 volts. To be honest, I'm shocked at my stupidity. This has all happened because I couldn't read this diagram properly. My excuse is the order of the writing, red, yellow, blue on here, doesn't match the diagram. Not a very good reason, but combined with the fact that the wiring on the actual plug which I bought doesn't match the colours either. But essentially it's my own stupidity. So due to my own stupidity, I thought I had a dodgy alternator and then another dodgy alternator. So what happened? The first alternator that was been on the car for several years didn't work because there was a loose bracket and it wasn't earthing itself properly. I think that's now what we know to be the case. That bolt was loose in the summer, and obviously if you've only got you haven't got proper earth connection to the alternator, then it probably isn't going to work, and indeed it didn't. So I finished up refitting that bolt, but it still didn't work. So I thought, oh my goodness, I've blown up the alternator due to having a loose bolt. That was my thinking. So I'm making excuses for myself here. So I thought, well, okay, we'll buy another alternator. Put the other new alternator on, misunderstood the connections, and then that appeared not to be working either. But what I've just discovered is that another video that I was watching to find out about how to test alternators by connecting the bulb to the power output connection on the alternator itself, that set of instructions unfortunately was wrong, because many, I don't know if it's about all, but certainly some alternators also need the 12 volt supply from the ignition to be there before they will work. So with my erroneous method of testing, I thought I had detected that both alternators were failed, but they weren't, and that's the bottom line. They weren't failed at all, and all it was that I misunderstood the wiring. So the breakthrough, if you can call it that, because I then had to go down to Car Builder Solutions in Maidstone to get another alternator, having assumed I'd blown the second one up by connecting it incorrectly. My attention was attracted by the fact that the third alternator appeared not to be working either, using the method on the bench spinning up with the impact driver. And I then thought, I wonder if the ignition needs to be connected. This one's obviously should be fine, it's brand new. Connected it, and guess what? It worked. So what this is all down to is I didn't know how to connect the alternator. So what do we have? In fact, what we have is quite well shown on this drawing by Bry's Automotive. Sorry Bry's, I didn't buy one of your alternators, but I did use your diagram. So we have the so-called Type 4 connector, which is the plastic plug which is on the car at the moment, and versus the Type 1, which is what I shall call a T-shape. So we have a stalk and a cross, and it appears that basically I had it the wrong way around on the T-shape. It was just back to front. Now why could it become back to front? I hear some of you possibly asking, because it was working before, right? And I think the answer is, what I haven't mentioned is that that 2020, I had the engine out to change the cam belt